Hello everyone and welcome to Physical Science. Today we're going to be talking about the behavior of waves. So behavior of waves, we see some waves here. What? You know what a wave is. Let's just keep going. Okay, first thing, the behavior of waves, we're going to talk about reflections. And a reflection is simply when a wave hits a surface and bounces back. So a wave hits a surface and it cannot pass through it, so it bounces back. You looking in a mirror is a reflection of light waves hitting a mirror. They can't pass through it, and it bounces back and hits your eyeball. That's why you see you. So this is a reflection. Bam! This is a reflection. Bam! This is a reflection too. And when you call down a hole, what is going to happen? The sound waves are going to go down, they're going to hit, and they're going to bounce right back. Now there is a caveat to this reflection thing. There is the law of reflection. The law of reflection says that the angle of incidence, the angle of incidence is what it hits at, is equal to the angle of reflection, what it bounces back. So we're going to draw in a picture to represent this. If you have a light ray coming in at, let's say, a 30-degree angle, guess what? It's going to bounce back at 30 degrees. It doesn't matter what this actually is. It could be anything. So whatever angle it bounces in at, X angle, it will bounce back at that same angle, just opposite. So that is the angle, or the law of reflection. Second one, refraction. Notice the difference between reflection and refraction. Refraction is very different. In this pencil, you can see that the pencil is in the water, but it looks like it's bent. It's like when you are trying to look in the water at something and you grab at it and you don't quite hit it. Well, that's because of this thing called refraction. So a wave enters a new medium. That just means it enters a new substance like water or air or something like that. At an angle, one side of the wave changes speed. It's either going to speed up or slow down, and then it causes the wave to look bent. So it will bend the wave. So if it comes in at this angle, it hits glass, it's going to bend it a little bit, and then it's going to go back out and change back. So the medium that a wave is in determines what speed that wave can go. And if it's coming in at one speed and then it slows down, it will cause it to look bent just like this. The third one is diffraction. Diffraction is when something goes in, hits a barrier on either side, and then it slows it down and causes this like spreading out motion here. So diffraction is wave moves around a barrier or through an opening, and it bends and spreads out. So this is like two jetties at the beach. So you can see it right here, where the waves are going in at a straight angle, but these continue to go at the same speed, but the ones around the outside edge start slowing down, which causes this spreading action. So if you'll please draw in your notes two barriers, waves coming in, and then waves spreading out. This is diffraction. And you can see the wave is coming in, and then it hits the barriers, and then it causes it to spread out around jetties or inlets. The fourth type is interference. Now, this one's pretty interesting. You can have constructive or destructive interference. Constructive means to build up, like when two waves combine together. So when two or more waves overlap to form a new wave. So let's say that we have one wave going this way and another wave going this way, and they end up combining. They would create a larger wave. Okay, so that's only if you have them going in the same direction at the same speed. However, you can also have destructive interference where one wave is like this and one wave is like this, and then it causes it to completely cancel out because one is equally as high as the other one is low, and then you end up with a net of nothing. So waves can interfere with one another. They can either combine or they can detract. So if you were to push waves in the same direction, your waves may build up. This is how waves at sea work, is they build up and up and up because you have them in addition. So that would be interference. And I want to point out one last thing from surface waves. this little guy here, when you see them moving on waves, technically all you're doing is this. You're rotating up and you're rotating down. A surface wave is only going to rotate through up and down. Notice the duck doesn't move. So surface waves are going to transfer energy, but they will not transfer a substance. It will just bob up and down, up and down, up and down. But the energy will be transferred, not the object. So waves transfer energy, not the material which they move through. So water will actually not be displaced. Water it looks like it's going this way when you watch a wave, but technically it's not. It's just rising and falling and rising and falling, and the energy is transferring from left to right, but the water itself isn't. So that is waves. All right, everyone, you have a wonderful day. Yay!